All right, so this is question number 4, January 2020. A says the function f of x is defined as f of x is equal to 2x plus 7 over 5. We're to find the value of f of 4 plus f of minus 4. Well, no, f of 4 plus f of minus 4, that would be the same as saying 2 times 4 plus 7 over 5 plus 2 times minus 4 plus 7 over 5. All right. So for f of 4, for both f of 4 and f of minus 4, in f of x, wherever you see x, you would take out x and put 4. That's when you're finding f of 4. And when you're finding f of minus 4, wherever you see x, you would take out x and put minus 4. 2 4s are 8. 8 plus 7 is 15. So this is 15 over 5. Plus 2 times minus 4 is minus 8. Minus 8 plus 7 is minus 1 over 5. So what we have is 15 over 5 minus 1 over 5. The final answer is 14 over 5. Or if you want, it is 2 and 4 over 5. So f of 4 plus f of minus 4 is 14 over 5, or 2 and 4 over 5. All right, let's continue. We're asked to A, calculate the value of x for which f of x is equal to 9. Now, f of x is equal to 9. F of x is 2x plus 7 over 5. And this is equal to 9. Now, our job now is to determine the value of x. If one fraction is equal to one fraction, I would cross multiply. So 1 times 2x plus 7 is 2x plus 7. Is equal to 5 times 9, which is 45. Positive 7 goes over and become negative. So 2x, I'm guessing would be equal to, this looks like 38. Then I'm going to divide both sides by 2. And so therefore, x is equal to 19. So if the value of x for which f of x is equal to 9 is x is equal to 19. Now, so IIB says, hence or otherwise, determine the value of f inverse of 9. Now, you could do this one of two ways. You could work out f inverse and then put in 9, or you could use the fact that f inverse of x is the solution of f of x is equal to 9. I'll say that again. F inverse of 9 is the solution of the equation f of x is equal to 9. Now, we just solved this and we got x is equal to 19. Therefore, this is my answer. F inverse of 9 would be equal to 19. Ladies and gentlemen, we're asked to hence or otherwise determine the value of f inverse of 9. I use the fact that f inverse of 9 is the solution of the equation f of x is equal to 9. So whatever the solution of the equation f of x is equal to 9, that is the value of f inverse of 9. So F inverse of 9 is 19. All right, this part of the question is on coordinate geometry. And we are told that the graph below shows two straight lines, L1 and L2. L1 intersects the x-axis at 4, 0, and 0, the x and y axes at 4, 0 and 0, 2, respectively. L2 intersect the x and y axes at 1.5, 0 and 0, -3, respectively. We are to determine the equation of the line L1. First of all, the equation of a straight line is in this form. Y is equal to mx plus c. The unknown here is m and c. In other words, if I know the gradient and see the y-intercept of a straight line, I would know the equation of the line. All right, so where does that lead me? So here's what we know about L1. It intersects the y-axis here, which is 0. This is the point 0, 2. And it intersects the y-axis here, which is 4, 0. So we could use those 2 points and find the gradient. All right, so the 2 points are 0, 2 and 4, 0. Those are 2 points on the line L1 that was given. We could have used any 2 other points. All right, but since we have these 2 points readily, we could use any 2 points. And the reason for that is the gradient of a straight line is a constant. So I could call this x1, y1, and call this x2, y2. Now, based on the fact that the line is sloping down, we're expecting the gradient to be negative. So m is equal to y2 minus y1 over x2 minus x1. This is equal to 0 minus 2 over 4 minus 0. This is minus 2 at the top and 4 at the bottom. The gradient here is minus a half. So the gradient of the line L1 is minus a half. Now L1 cuts the y-axis at 2. So that point here, this is the y-intercept, which is C. So C is 2. So I have both the gradient and I have the y-intercept. The gradient I found by calculation, and the y-intercept C I determined by inspection. Once I know the gradient and the y-intercept, I know the equation of the line. So the equation of the line L1 is y is equal to m, the gradient, minus a half x, plus c, the y-intercept, which is 2. So y is equal to minus a half x plus 2 is the equation of the line L. All right, the last part of the question. This says, what is the gradient of the line L2 given that that L1 and L2 are perpendicular lines? Well, 2 things you have to remember are one thing essentially, and the implication of it. The product of the gradients of perpendicular lines is -1. And the implication of that is this. If I know the gradient of a line, to find the gradient of a line that is perpendicular to this line, I must invert the gradient and change its sign. So M1, which is the gradient of L1, so this is for L1, the gradient is minus a half. Now M2, which is the gradient of L2, would be positive 2 over 1, which is just 2. So the product of the gradients of perpendicular lines is -1. If I want to find the gradient of a line perpendicular to a given line, I must invert the gradient of the given line and change its sign. All right, and that I believe is the end of the question.